In section 5.3, we're going to look at how we evaluate definite integrals and antiderivatives. First of all, we'll start with some of our properties of definite integrals. First of all, the order of integration. If I switch the limits on my integral sign, then the value of my integral becomes negative. The second rule says if I'm integrating from a to a, obviously I'm not accumulating any area, so that value is going to be 0. The constant multiple rule says if I have a constant in front of my function, I can bring the constant out front, find the integral, then times by the constant. The sum and difference rule says if I'm taking the integral of two functions that are added or subtracted, I can take the integral of each one and add and subtract them individually. And the additivity rule says if I take the integral from a to b of a function and I add to it the integral from b to c of the same function, that's really the same thing as going from a to c. All right, let's see how we apply these rules. So say we're given the following. We're given that, we'll just look at the first one here, that the integral from 0 to 5 of f of x dx equals 10, and the integral from 7 to 5 of f of x dx is equal to 3. We want to find the following. So we want to find, let's do part A, where we're asked to find the integral from 0 to 7 of f of x dx. So to find the integral from 0 to 7 of f of x dx, this is question A. I'm going to use the additivity property, so I'm really finding the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx. So the integral from 0 to 5 was given to me as 10, plus the integral from 7 to 5 is 3. So if I add those two together, I get an answer of 13. Okay, I'm going to leave the rest of these questions for you to try in your assignment, but that's kind of the first one. And again, just look at your properties and you should be able to apply your way through those. Okay, our next example says we have a continuous function such that the integral from 8 to 0 of f of x dx is negative 13, and the integral from 0 to 2 of f of x dx is equal to 8. What is the integral from 2 to 8 of f of x plus 4? So let's start with the integral of 2 to 8 of f of x plus 4. So the first thing I'm going to do is I'm going to break this up. So this is really the integral from 2 to 8 of f of x dx plus the integral from 2 to 8 of 4 dx. Okay, and to figure out the integral from 2 to 8, okay, I'm going to use the given values that I have up here, but I have to switch these around a little bit. So I am going to flip the integral 0 to 2 to make this become the integral from 2 to 0 of f of x dx plus the integral from, and I'm going to flip this second one around as well and say this is the integral from 0 to 8 of f of x dx. And then I have to add to it, and again, this guy here is the integral of a constant, which we talked about last time. So this part is really going to be the constant times 8 minus 2. Okay, so now to finish this one off, the integral from 2 to 0 is the negative of the integral from 0 to 2. So this is going to be negative 8 plus the integral from 0 to 8 is going to be the negative of negative 13, which is positive 13, plus 4 times 6 is going to be 24. And if I work that out, I am going to get a total of 29 as my answer. Okay, in our next example, we're given some information. We're told that the integral from negative 6 to 5 of the function f is 7. And we're asked to find the integral from negative 6 to negative 2. And unfortunately, negative 6 to negative 2, there's no graph of that, but I do have enough information to figure this out. We know that this portion of the graph is a quarter of a semicircle with the center at the point 5 and 3. So we're going to use that to help us find the area under the curve from 2 to 5. But let's first of all figure out that if I can find the area from -2 to 5 on this graph. So the first thing I'm going to do is I'm going to find the integral from -2 to 5 of f of x dx. And this is going to equal, well, first of all, I have a triangle that's above the x-axis, and it's going to be 1/2. The base is 1 and the height is 1. Then I have a triangle below the x-axis, and that base is 1.5 and the height is 1. So it's going to be minus 1/2. Base is 3/2 and the height is 1. Then I'm going to find this triangle, which is a base of, again, 1.5 and a height of 3. So it's going to be plus 1/2 3/2 times 3 plus, now to figure out this area under the quarter of a circle, I'm going to take this whole square, which is 3 by 3, which is 9, and I am going to minus the area of this quarter of a circle. So to figure out that last part, it's going to be 9 minus a quarter of a circle is 1/4 pi r squared, and the radius of this circle is a radius of 3. So this ends up being 1/2 minus 3/4 plus 9/4 plus 9 minus 9 pi over 4. So if I collect like terms, I am going to get, this is going to be, I'll just change this to 2/4. So this is going to give me 11/4 minus 3 is going to be 8/4. So this part here combines to be 2 plus 9 minus 9 pi over 4. And this works out to be 11 minus 9 pi over 4. So that's the area from -2 to 5. But we're asked to figure out the area from -6 to -2. So we have to come up with an equation to do that. So if I want to find the, we know that the integral from -6 to 5 of f of x dx is going to be equal to the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. Again, using that additivity property. Again, it stops at -2 there, it starts there. It's really the area from -6 to 5. So these two things are equal. Okay, and going back to what's given, we know that the area of from -6 to 5 is 7. Equals, well, this is what I'm looking for. And we know that this area here was 11 minus 9 pi over 4. I guess I really don't need the bracket there. Okay, so now to get this guy by himself, I'm just going to move those terms to the other side. So this is going to be 7 minus 11 plus 9 pi over 4 equals the integral from -6 to -2 of f of x dx. And again, on the AP exam, you don't have to simplify. You could leave your final answer like that. Okay, let's take a look at some of our basic integration rules now. Now we're going to look at how we integrate things manually, find a definite integral manually without having to use our calculator. And we see the integral of a constant is just a constant x. The integral of a variable x raised to the power, I add 1 to the exponent and divide by the new exponent. So this one here is the one we're going to use quite a bit. And we'll reference some of these other ones as we go through our examples, but we'll keep referencing back to this page. So we want to evaluate the following definite integral. So the first thing I want to do is I want to find the integral of 2x. So basically, what function, when I take the derivative, do I get 2x? Well, here's how we do the integral. We basically have this as our integrand. And to find find this integral, we add 1 to the exponent and divide by the new exponent. Well, if I add 1 to the exponent, it becomes x squared. I still have my 2, and then I have to divide by the new exponent, so the 2's are going to cancel. And I'm evaluating this from 3 to 5. So this really means I plug 5 in, my upper limit, my integral, and then I plug in my lower limit. So then I just do the math here, and this integral is going to equal 16. Okay, so for this next example, what I need to do is I need to integrate each term in my integrand. So the integral of 2x is going to be x squared. The integral of 3 is 3x. And if you want to check if you're right, if you take the derivative of this, you'll get back what you started. And now I want to evaluate this from 1 to 4. So first things first, I plug in my upper limit of 4. And then I plug in my lower limit of 1, and I subtract the 2. So 16 plus 12 minus 1 plus 3. So 28 minus 4. This area is going to be 24. All right, the integral of cos. Now, I'm going to give you a little chart that might help you memorize your integrals and derivatives of trig functions of sine and cos. Now, going down is the derivative. Going up is the integral. So I want to find the integral of cos. Well, I start at cos. If I go up, the integral of cos is going to be sine x, evaluated from pi by 3 to pi by 6. This equals the sine of pi by 3 minus the sine of pi by 6. So I'm going to need my 30, 60 degree triangle. And the sine of pi by 3, oh, I got those backwards, don't I? This should be pi by 6, and this should be pi by 3. And it's my upper limit minus my lower limit, sorry. This should be pi by 6, this should be pi by 3. So the sine of pi by 6 is a sine of 30, which is going to be opposite over hypotenuse, so that's going to be 1 over 2. And the sine of pi by 6 is the sine of pi by 3 is the sine of 60, which is root 3 over 2. And that could be your final answer. Now, some textbooks might combine them into one term, but they would probably give their answer as an exact value. Okay, in this next one, I want to find the integral of sine 5x. Now notice the integral of sine is negative cos, but notice in this example, I have a 5x here and just not a 5. And remember, when we took the derivative of sine 5x, whoops, the derivative of sine 5x, we would take the derivative of the trig part, leave the function alone, and then times by the derivative of the inside. Well, when we find the integral, we do the exact opposite. We take the integral of the trig part and we divide by the derivative of 5x. So the integral of sine, if I go up the chart, is negative cos. So this is going to be a negative cos 5x. And now I'm dividing by the derivative of 5x, which is 5, from pi by 30 to pi by 10. So this negative 1 and 5 can be a constant, so I'm going to bring it out front. And then I have cos 5x going from pi by 30 to pi by 10. So this is going to be the cos of 5 times pi by 10 minus the cos of 5 times pi by 30. So this is going to be the cos of pi over 2 minus the cos of 5 pi over 30, which is going to be pi over 6. So this is going to equal negative 1/5. The cos of pi by 2 is 90 degrees, and the cos of 90 is 0, minus the cos of pi by 6. I need my triangle again. Pi by 6 is 30 degrees. Cos is going to be root 3 over 2. And if I multiply these together, I'm going to get positive root 3 over 10. and that would be my final answer. So again, the only thing you gotta be careful of is if you have a function bigger than x in here, you integrate the trig part, leave the function alone, and divide by the derivative of the exponent, or of the function. Okay, this next one, I have e to the x, and again, if we look back at our derivative or integral rules, the integral of e to the x is simply e to the x, because the derivative of e to the x is itself. So the integral of e to the x is e to the x, evaluated from ln4 to ln6, so this equals e ln6 minus e ln4. And if we go back to our properties of exponentials and logs, okay, if I have e raised to an ln, it just ends up being whatever numbers inside the logarithmic function, and e to the ln4 ends up just being that. So this ends up being 6 minus 4, which is going to be 2. The integral of 1 over s ds. Now, if I move that s up to the top, I would get s to the minus 1. And now if I added 1, I'd get 0, and then I have to divide by 0, and I can't do that. So this is a special case. And if you remember way back when we did derivatives of exponentials and logs, the derivative that was 1 over was the logarithmic function. So if I integrate 1 over s, that's going to be equal to ln absolute s, going from 5 to 10. That's going to be the natural log of 10 minus the natural log of 5. And reviewing our laws of logarithms, if I'm subtracting two logarithms, I can combine them by 1 if I divide. This is going to be ln2. Okay, this one here is a little bit tricky. So the first thing you need to do is you need to divide each term in the numerator by the denominator. This is going to equal the integral, well, not negative. So this is the integral from 1 to 3. W squared over W is W plus 1 over W with respect to W. And now I can integrate. The integral of W is going to be W squared over 2 plus the integral of 1 over W is going to be ln absolute W. And this is going from 1 to 3. So this is going to be 3 squared over 2 plus ln 3 minus 1 squared over 2 plus ln 1. So this ends up being 9 over 2 plus ln 3 minusing 1/2, and ln 1 is equal to 0, so that drops off. So my final answer, 9/2 take away 1/2. I'm just going to put it up here. 9/2 take away 1/2 is 8/2, which is 4, plus ln 3 would be my final answer. All right, here's a multiple choice question from the 2003 exam, and it says we want to evaluate the integral from 0 to 1 of e to the negative 4x dx. Well, this is similar to our trig function earlier, so notice my exponent is not just x, it's negative 4x. So when I integrate this exponential, it's going to be itself divided by the derivative of the exponent, going from 0 to 1. Again, there's really a 1 and a negative 4 here, so that becomes my coefficient of negative 1/4 e to the negative 4x going from 0 to 1. So this is going to be negative 1/4 e to the negative 4 minus e to the 0, which is going to be negative 1/4 e to the negative 4 minus 1. And if I was to distribute the negative 1/4, I would get negative e to the negative 4 over 4 plus 1/4. And if I change the order, it would be that answer right there at D. So again, with an exponential, you have to be careful. If the exponent is bigger than just x, you have to divide by the derivative of the exponent. Okay, we're going to pause the video there. We'll continue this in our next video when we look at some more applications from the AP exams of definite integrals.